Professor Wergeles here. We just got done going over the ready method and passing the stage. Let's take a look at how to create a thread. The first way that we learned was to extends the thread superclass. So if I extends the thread superclass, right now my custom class counter thread is technically a thread. I didn't define the run method, so right now there's no asynchronous task, but it is a thread. This thread superclass actually has the run method. So if I do a show Java doc, you can see what's in this thread superclass. Okay, what's in here? So you'll see here prime thread, extends thread. We've already done this. You need to define the run method. We haven't done this yet. You can read about this. I actually recommend you read this and the Java docs. Get used to reading docs, whether you're implementing in Java, Python, Go, or any other language that you're doing or implementing. You'll want to be familiar with the docs. So you'll see here's what's inside of this class. I have constructors and I have these methods. So if I scroll down, you will see that I have the run method. You'll see if this thread was constructed using a separate runnable run object, then that runnable object's run method is called. Otherwise, this method does nothing and returns. So it's basically an empty method. Okay, it's basically an empty method. It does nothing and returns. So we need to override this method. And the code that we put here is going to be running asynchronously, or you can consider it as a concurrent program. So I can do multiple things at the same time. So that's what we're talking about, Java concurrency. If you go back to the slides, make sure you know what concurrency is. Make sure you know what processes and threads are. Make sure you understand the difference between the two. So when I do public void run with no parameters and an empty block of code, you'll see I get a warning here. It's saying, hey, I see this run method in the superclass. Are you trying to override it? You'll say, yes, I am trying to override this method. So we do. And now what do I want to happen concurrently? Well, I want to just have a basic for loop. I have a basic for loop that starts at 0. So I is equal to 0. We'll say I is less than the count 2, which was passed into the constructor. And we'll just increment I every one step. So every step will increment I by 1. And all we're going to do is system.out.print. We're going to print this to the console. So I'll say counter thread I is equal to whatever the I value is. Make sure you put a space there so the output's nice and neat. And this is basically how you do it. Now you'll see I have a Boolean stop and I have a count 2 variable. Right now it's at 0. But when I call the constructor, I pass in the count 2. The for loop will count to that number that we passed in, that integer. And then the for loop will exit. The run method will finish. And this thread will be terminated. Okay, that's how easy it is to make a thread. So the basic way to make a thread is to extend the thread superclass and override the run method. These are going to be quiz questions. These are going to be on the exam. So you want to know this. The run method is very important. The run method is where you put your code that's going to run once the thread has been started, once the thread's been created and started. Now let's see this work. Okay, let's see this work. So I go back to the controller. Let me open up the UI so you can see what it looks like. Okay, if I open up the UI, you can see what this looks like, and we'll program a few different threads. We'll use our own custom classes, and we'll even implement a thread without its own class. So you see I have start, pause, and stop. Okay, these are going to be for different threads. So I'm going to use this one for counter thread number 1. So when I click this start button, I want the thread to start. So you'll see handle start 1. So you'll see counter thread is called thread 1. So first, we need to instantiate that class. So thread 1, we'll say new counter thread. That's the class, that's the constructor. And we can count to a specific number. So at first we can start kind of small. Let's see, maybe we do 100. Okay, maybe we do 100, maybe we do 1,000. Now, if I save this and just create a new instance here, save it and run it, okay, the question is, will the thread run? If I click start button was pressed, the thread is not running. It should be outputting to the console. So the thread will not start until you call the start method. And what's important to note is this start method is only in the thread superclass. So if I go back to the docs, okay, you'll see here I'm in the thread superclass. The thread superclass has one superclass called object. I scroll down, it has a start method. This causes the thread to begin execution. The Java virtual machine calls the run method of this thread. So what I'll see a lot of students do is they'll say, okay, thread, let's call the run method. You'll see here I get a warning, invoking run on the thread. I'm guessing this will probably create a runtime error. And even if it does work, it's not a proper programming practice. So if I run it, I'll see a lot of students do this and they get this wrong on the exam. So look, it actually did work, but that is not correct. You want the JVM to handle it. So you want to call the start method. Don't call the run method. Don't get that wrong on the exam. A lot of students use threads on their final project. So if you implement this on your final project and you want the bonus points, make sure you implement it correctly. So if I do start, you'll see it also starts. And look how instantaneous that is. Okay, just boom, done. So if you wanted to actually see it run for a while, you can increment it. So maybe instead of 1,000, okay, here is 100,000. So maybe I do 1,000,000. So if I save this and run it, okay, we can make this program better. Maybe we have an input, like you have another button that says count 2. You click in and you can input a number. So I click go. You'll see it actually takes a little bit longer this time. And that's why the algorithms in an interview are so important. Look how long this for loop is taking to go to 1,000,000. So if I have 1,000,000 elements, and let's say I have a double for loop, a big O n squared algorithm, I have to check every element compared to itself. That's not a good algorithm. That's not efficient. So when you're interviewing for Facebook or Google or any of the big companies, make sure you're writing efficient code. Okay, big O of n is a pretty good algorithm, but if you can get quicker, that's even better. Okay, you don't want to go much longer than big O of n, although sometimes you have to. Sometimes you have to do recursion, and the quickest one is n squared or n whatever. But try to make your algorithms as efficient as possible. Look how long this is taking. Okay, just to count to 1,000,000. So think about if I was doing some computation where I'm multiplying or sorting or checking other elements compared to itself. Okay, now we are finally at 1,000,000. Okay, so I'm going to reduce that a little bit so we can actually see both elements run at the same time. I'm going to reduce it back down to 100 grand. Now, here's the thing though. So let's say I run this. Let's say I run this. So here's the program. Let's say I run this and the user closes the window. So I close it. Look at this. It's still running. Now I know how to terminate that and see once it's finished, it'll terminate. So I know how to force quit a program. You know, I go to my activity monitor or whatever on Windows, and then I force close. But my mom or some non-programmer doesn't know how to terminate these. So you want to make sure you're writing good code. So when they close the window, boom, it should terminate the program. Okay, I'm going to show you how to do that in the next video. Stay with Professor Wergeles, and we'll see you in the next video.